So this video is going to be focusing on the 6 different things that you would be expected to know about complex numbers as part of any sort of standardized test like the ACT. So the 6 things we're going to spend time on are what they are, simplifying, adding, subtracting, multiplying, solving, and the complex relationship. I want to be clear about this. We're not going to spend a super huge amount of time on any of these, but it's just a brief overview of each of the things that you may need to know. So first of all, what are complex numbers? Well, they're a solution that's been developed to a situation such as this, the square root of negative 16. If you were to try and type that into a calculator right now, what you would get is an error. Calculator can't handle something like this. But why? Well, if we think about what a square root means, it's a symbol denoting two numbers that multiply together that are exactly the same that make negative 16. That's why when we take the square root of, for example, negative 25, we get an answer of 5 or negative 5. Because these 5 times 5 would be 25. So they are exactly the same and they multiply to make our number inside. But there's no case that exists like that for negative 16, because in order to make a negative number, we need a positive and a negative multiplied together. So complex numbers have been developed as a way to deal with that sort of situation. The way they're represented is you see an I attached to a number. That means complex. So the basic idea is that the square root of negative 1 is I. So let's look at some simplifying. When we're simplifying a square root, there's a lot of different ways to do this. This is my personal favorite. I like to split the number into 2 different pieces, especially when I'm dealing with a negative square root. I split it into a piece of negative 1 times the positive version of whatever number I'm talking about. So in this case, 25. So according to our rule, here, the square root of negative 1 is I. So here, that would mean this piece becomes an I, and then I can take the square, or I can simplify the square root of 25 just as I normally would. So I know the square root of 25 is just 5. So that means our solution is 5i. So this would be the square root, or the simplified version, of the square root of negative 25. Trying again. So negative 1, positive 162. This becomes an I, and then I would go through the process of simplifying this as I would any other square root, splitting it out into a perfect square and a non-perfect square of some kind, and then simplifying. And one last time. So if I'm ever not sure about a number being divisible by a larger perfect square, I'll try a smaller one personally. It just seems to work better for me. So this becomes 2i. But that could simplify further. It's divisible by 16. So I get a solution of 8i square root of 3. So that's simplifying. Once we move into adding and subtracting, the basic process is actually following the same thing as you would do with any other type of polynomial, where you take like pieces and you combine them. So in this case, I have a real piece, a number that doesn't have an I, and a complex piece or an imaginary piece. Then I have the same over here, real and imaginary. So when I'm adding or subtracting, doesn't matter, I take my real pieces and combine them using the symbol in the middle, and I take my imaginary pieces and I combine them using the symbol in the middle. So if I wanted to rewrite this expression, I would rewrite it as 8 plus negative 3 plus 5i plus 2i. So 8 plus negative 3 would be 5, 5i plus 2i would be 7i, and that would be my solution. Same thing here, take my reals and add them together, so I get 4. Take my imaginaries and add them together, so I get negative 9. Subtracting is the exact same thing. It's just important to make sure you keep track of your symbols a little bit more carefully since subtracting flips symbols on some things. So 12 minus 8 would be 4. 2 minus negative 4 would be plus 6i. And that's because of the minus a negative symbol. So negative 9 minus 4, negative 8 minus 5, and those are our solutions. So adding and subtracting is just combining like terms, basically. Multiplying, however, is a little bit more difficult. I prefer the box method. You may be somebody who prefers FOIL, but it behaves the same way. So if I were to solve a problem like this, I would set it up using box method and multiply my pieces. So 7 times 2 gives me 14, 21, and then just an I attached to that, just like you would with an X. The part that gets interesting here, though, is once we get into this point, this number is something we haven't dealt with yet, where we have an I squared. Now, we said before the relationship was the square root of negative 1 is I. So if we kind of play off of that relationship by squaring both sides to get an I squared over here, what happens when you take a square root and a square root of a number? They cancel each other out. So if I ever see an I squared, it's really just multiplying by negative 1. So my solution here is 14 minus 8i plus 21i minus 12 times negative 1. So then I can go through and simplify things. So 12 times negative 1 is negative 12, and since there's a negative sign up front here, it becomes plus 12. And then I just combine like terms, like we talked about with adding and subtracting. So same thing over here. Set up the box. It doesn't matter what goes on either side. Then we go through and simplify. So multiplying is a little bit more difficult just because of that squared piece, but that's just playing off of that relationship that the square root of negative 1 is I. Solving is a little bit more difficult. So you've talked about probably multiple methods of solving a quadratic, but we're going to be focusing on the quadratic formula. So that was negative b plus or minus the square root of b squared minus 4ac over 2a, where a comes from in front of the x squared, b comes from in front of the x, and c comes from the constant number. Plugging everything in where it belongs, I end up with this as my expression. So if I actually go through and simplify that a little further, I get the square root of negative 80 here. So the 2 and the 6 we're going to kind of ignore for a minute, and we're just going to simplify that square root of negative 80. So just like we talked about with simplifying, split it out into a positive version of the number and negative 1. This becomes I. This would be divisible by 4, which would give us 20, which means that it's actually divisible by 16. So this number could be 4i square root of 5. Now that's handy for us because what that means is I can do negative 2 plus or minus 4i square root of 5 over 6. Now you've probably talked about simplifying a symbol like, or a situation like this with your teacher before, but in order to be able to simplify this, I need to be able to simplify all three of these pieces, so the 2, this piece and the 6 all by the same thing. In this case, they're all divisible by 2, which would mean my final answer ends up being -1 plus or minus 2i squared of 5 over 3. Now, the last piece of this is based on that complex relationship. For some reason, ACT really loves to talk about this relationship. The idea is that we've already said, let's go back to the other color here. Okay, I is the square root of -1. We said I squared was just -1, but then they like to take it a step further and say, okay, well, what if I took those two things and I multiplied them together and made I cubed? What would that be? And then they like to take it a step further and say, okay, what about I to the 4th? So if you think about it, I cubed would be I squared times I, meaning -1 times the square root of -1, because I squared is -1 and I is the square root of -1, which gives us a negative square root of -1. Then I to the 4th would be I squared times I squared. So they're looking at this pattern, this idea that I is the square root of -1, I squared is -1, I cubed is negative square root of -1, and I to the 4th is 1. They play off this a lot, where they'll say something like, well, based on what we know about complex numbers, what is I to the 27th power? And you're like, what is going on? What am I supposed to do with that? But they're playing off this idea, so they're looking for you to recognize this pattern. Because if you were to continue the pattern and figure out I to the 5th, what you would end up getting is the square root of -1. So the pattern repeats. So after 4, it repeats. So then they would ask you to just simplify this problem. Well, that would mean that the I to the 25th would be the square root of -1. So I to the 26th would be -1. So if I type in my calculator I to the 27th, I should get the negative square root of -1 as my answer. So they're just playing off this relationship. If I were you, I would keep track of this and kind of practice with it and play around with it, because that's usually what they're talking about. So, just as a reminder of all the different things that we talked about here, the complex numbers, what they are, simplifying, adding, subtracting, multiplying, solving, and the complex relationship.